Hello, everyone. So excited for you guys all to be here with me again. Just as a reminder, welcome in, welcome in. This is Rock Talk with Robin, and yeah, we're basically here to talk about rocks. I am the resident geologist here at Sage Goddess, and today I'm so excited because we are going to really deep dive into obsidian. So I just wanted to say, obsidian has always been an extremely special stone for me. Hi! Hey everyone! Obsidian has been such a special stone for me when I was extremely young. Hey everybody, hello, welcome in. My dad, as some of you guys might know, my dad's the one that really got me into gems and minerals. And when I was young, I was going through some really hard times emotionally. And my dad started taking me out rock hounding. He would help me find really cool places, and we'd head out, just him and I, in our truck, go around to these different areas. And luckily for me, living here in Southern California, there were a lot of areas where I could find different obsidians. Still, to this day, there is a mountain of obsidian in my dad's backyard, and he keeps asking me when I'm gonna come get it all. Hey guys! So, I'm so excited to talk to you guys about obsidian today. It has a very close place in my heart. It connects me with my dad, and it really helped heal me in a way and build me back up to be able to be who I am today and really go in, figure things out, heal that auric shield that was all going crazy. And so I want to explain not just the geological side, but how the metaphysical side of this stone really helps us all. There's so much about obsidian. That's why I really wanted to keep it to one stone this time and go into the different aspects of it. So kind of how we did with the garnet and the kyanite last time, but we're just going to do the one and really deep dive. You guys ready for that? You guys want to do that with me? I'm excited. Oh my gosh. Hey Polly, hey Deb. Hi Nita. And the other side that I'm going to do is, you know, that debate on tektites and agni? I did, before this, earlier today, I did a really cool experiment where I took obsidian, true tektites, and agni, tested them all, and I'm going to explain that to you later and show you my results. Oh my gosh, I was bouncing downstairs as best as I can bounce right now with my bad knee. And Aziz was there helping me, and we full on started just squealing. We were so happy with our results. So let's get started. Because you know I get so excited. Okay, so obsidian. Obsidian is found in many locations all over the world. So it is one of those really cool stones that anywhere that there's volcanic activity, you're going to find some obsidian. And so, but the thing that's also cool about it is the obsidian that's around now. Oh, Deb, I'd love to know how it's a special crystal for you too. I love people's stories. So, obsidian is a new stone. It doesn't matter what obsidian it's going to be a newer stone. Any obsidian that's older than a few million years is extremely rare to come by because of the structure and how it is. Because it is a glass, it breaks down. So over time of weathering, heat, other processes, it's going to break that obsidian down and basically put it back into the earth for Gaia to be able to use again and bring it back to you in another form. Might be another form of obsidian. Because there's so much silica in it, Gaia might take that back and turn it into quartz or feldspar. You don't know. So it's a new stone, and every piece is going to be, and I mean, we are talking geology. So like I said, a few million years is still considered a new stone, considering some of our stones that are here are just so mind-blowingly old. Some significant deposits of obsidian. So the main areas where you're going to find it are places like Argentina, Canada, Chile, Ecuador, Greece, Guatemala, Hungary, Iceland, Indonesia. That's a big one we're going to talk about later. Italy, Japan, Kenya, Mexico, New Zealand, Peru, Russia, and the United States. But the thing is, though, is in the United States, you're only going to find obsidian west of the Mississippi. You're not going to find obsidian east of the Mississippi River that was naturally occurring there. And that's simply because there's no geological recent volcanic activity there to have created it. In the western U.S., it is found, the main areas where you're going to find it is Arizona, California, Idaho, New Mexico, Oregon, Washington, and Wyoming. And most of the obsidian you actually see in the jewelry trade right now is coming and being produced here in the United States. So for those of us that are here in the States, that's a fun fact. So now I'm going to get into how obsidian is formed, because there's a very specific way that it forms in order for it to be really a true obsidian. So it is an igneous rock, and that forms when molten rock material cools rapidly, that atoms are unable to arrange themselves into a crystalline structure. And so we call that an amorphous mineral known as a mineraloid. The result is volcanic glass that is smooth in texture and that breaks in a very specific fracture, which I'll show you coming up. It's called a conchoidal fracture. Hey, Rosa! The other thing that's really cool is most stones grow in an intrusive form. That means that it grows within the earth, and then it either has to be dug up or it's unearthed due to weathering. Whereas obsidian is almost completely an extrusive stone, which means it was created above the earth's surface. So some ways that happens is along the edges of a lava flow. So where the lava is flowing after that volcanic eruption, in the middle it's still molten, so it's not obsidian yet, but along the edge where it's cooling, it'll turn into obsidian. Along the edges of a volcanic dome, so where it's all molten inside, but it hasn't like erupted yet, but it's touching, there'll be obsidian around there. Anywhere where lava contacts water, because that lava hits that water and it cools so fast, it's going to make obsidian. And then anytime where there's an eruption, so the lava gets flown into the air cools it so fast that you're going to have little nodules of obsidian that's cooled in the air right there. There is one way that I know of where it can be created intrusively. So when it's created intrusively, that's around the edges of like sills or dikes. That's the only areas that I know of where it can be intrusive. So I'm going to take you through the different steps now of formation. So I think it's fascinating. I hope you guys are going to be as excited as I am. And so the first step number 1, is magma formation. So that magma has to form. And what happens with that is it's deep within the earth, and it's down where the mantle of the earth is. And that's where different rocks are under such high temperature and pressure that the earth is just like on it, and it makes it molten. So that's where it gets all just like jelly-like and like gooey. And then we go into the next step, which is a silica-rich composition. So where that magma is, where it's all jelly-like deep in the earth, silica-rich like whether it's just like water or other goo, however it is, wherever it is, has to be introduced into that magma. So here's all the hot, bubbly, boily, and then these other trace minerals of silica come in. And have you guys ever seen like taffy when they're making it and it's molding, and then they add that color in and it just kind of like molds through? That's how I see it in my head. And then so like all that silica is going in there and it's molding around and boiling around in like this thick goo. And there has to be at least 70 to 75% silicon dioxide, which is your silica, to enter into that magma in order for it to turn into a magma that can create an obsidian. So after that all has happened, then there has to be that volcanic eruption. So with that volcanic eruption, the magma has to come out. And you have to remember, there's different types of volcanic eruptions. There's the ones that go boom. There's the ones that just kind of like ooze out. There's the ones that do little sprays. I'm not a volcanologist, so I can't say off the top of my head all the different volcanic eruptions. I don't remember them. But it's pretty easy to look up. But so with the eruptions of the different types, that's going to tend towards your different kinds of obsidians. But in general, it's that eruption, and the magma is expelled to the Earth's surface. So it goes from way down deep, and then it comes out, whether it's slow or that big kaboom, like I said. But it comes out through vents, fissures, and with that, the rapid ascent of the magma is driven up by the pressure buildup beneath the Earth's crust. So after that, now we can start cooling. And so I know you guys know that there's lava stone, and then there is obsidian. Lava stone is going to cool slower. And because it cools slower, it has time for a crystalline structure to start to form. And that's why you're not going to get that glassiness. For the obsidian, it has to cool so rapidly. So as I was saying before, it is exposed to the relatively cooler temperatures of the Earth's surface to cool rapidly. Water, different areas, but it has to go so fast that there's zero time for it to get any type of crystalline structure. This can happen within seconds. And that means it goes to our next one, solidification. The lava solidifies so quickly, and like I said, it can take a process of seconds to make obsidian from the time it came out to it's done. And that's the other difference. So many stones, it takes so long to create. Not obsidian. Done. The longest it can take to make an obsidian is like a minute. Anything longer, and the structure is going to be growing. So you're not going to get that glass that you see in the obsidians. So then we go back into that lack of crystalline structure like I was talking about. And it's simply because, do you guys know how atoms are? Where you have your nucleus and then you have your electrons going around it? Because this happens so fast, they don't have time to arrange. So that means that the electrons that are extra in those atoms don't have a chance to connect and make that structure. It's all kind of like, there's one here, one here, one here, one here. And so that's what creates that glass. Then I told you we'd talk about that conchoidal fracture. And I actually have a piece I broke, and I wanted to show it to you. Yes, you are going to see obsidians today, guys. Don't worry. I have lots to show you. But here, do you see how it broke? And do you see how it kind of made that dome? That is what I'm talking about, is that dome. Whenever an obsidian breaks, a true obsidian, you're going to have that fracture pattern. And it's going to be nice and thin like that. Here's another piece. See that? See how it makes those little domes? That's that fracture I'm talking about. When obsidian breaks, it exhibits this fracture, and with that, it creates these really, really sharp edges. And you have to be careful with obsidian. This can and will cut you. I mean, you barely touch obsidian in a certain way, and watch out, you're going to need a Band-Aid. Then there's the different variability of the colors of obsidian. I know you guys know there's so many different types, like there's your sheens, there's your rainbows, mahoganies. And the color and appearance of the obsidian can vary widely depending on factors such as impurities and mineral inclusions present in the lava itself. So those trace elements, as that silicone is being like put in, those other elements have to be put in at that time to create the specific color. These variations give rise to different varieties of obsidian, ranging from black to brown, green, red, and then even the very translucent and banded patterns. Then there's your geological setting. Obsidian is commonly found in volcanic regions around the world, typically associated with the eruptions of rhyolitic or dacitic lava, which are high in silica content, going back to what we learned at the very beginning. So with that, for right now, do you have any questions on that part? Because from there, I'm going to go into the different kinds of obsidian and explain how that's created. But before we get into that, do you guys have any questions on the formation? Let me know. Put it in the comments and I'll answer the best I can. I love the arrowhead obsidians too. And the reason why they were able to do that with those arrowheads is because of how it fractures like that. They figured out that they could take another stone and flint knap it, and they would make those little conchoidal fractures that you go down where you see those little dips. And that's what they were able to do that. You go evenly on both sides, flint knap. You got an arrowhead that's super sharp. So that's just from the stone itself. If there's no questions yet, I'm going to go right into some of the different varieties of obsidian and explain how those colors came in, or those different sheens. So in order to start with obsidian, I always say we got to start with the black obsidian. Black is the most common color of obsidian. However, it can also, in just the black itself, it can go a little bit more to the brown side, a little bit more to the tan side, or a little bit more to the green side. And rarely obsidian can be blue, red, orange, or yellow. And those are all due to the trace elements and inclusions in there. So here is... Sorry for my fingerprints. But this is an obsidian scrying mirror. If you see, you can really see the reflection on there. And that is because it truly is glass. You can kind of hear it too. Obsidian is the first form of glass that we knew on this planet. And you can see here how shiny it is. And a true obsidian is going to be able to get this shiny. And a lot of times, even as you can see on broken pieces, It's that shiny without any polishing. So when you have a piece that you can polish up a little bit, it can go so shiny. And I love this piece because it actually has a little bit of sheen on the edge. And then if you look after that, if you look at my little Metatalian I have here, this is what happens when you scuff up black obsidian. So what they did here is they took a fine like grit and they rubbed it all over this to make it so it has this more of a whitish texture. And that was to make it so it stands out. So you know when you accidentally scratch your mirror? And that's basically what they did to the glass to create it like this. Oh, that's really cool information, Karina. That's really cool. I'm actually going to Hawaii at the end of this month. I can't wait to see see it out there. It's gonna be my first time. Then, depending on where it is coming from, you're going to have different levels. So this obsidian here is from Pakistan. And do you see how there's a little bit more open areas? Remember how I said it will cool at different rates? Some obsidians that are really glassy, like this, is an obsidian that cooled in seconds. This here, where it has more open areas, is going to be an obsidian that is more closer to that minute of cooling. And that's why it looks more rough and closer to a lava stone than an obsidian. But when it breaks, as you can see, there's still glassiness to it. It does almost look like dark amber, right? And then I grabbed this piece because there's an area here. Do you see the green? That's a natural formation of green obsidian due to trace elements that were in there, which is really cool. Green obsidian is not very common. You don't see it all the time, but when you can find a piece that has that natural green, I always say grab it because you never know if you're going to see that again. And most green obsidians that you see on the market are not real. It's man-made glass. But when you see it like this, where you have that trace in there, that is real. This sphere here you see how it has that green tint? This is a real true green obsidian. You see how it's not that bright green, that like translucent green? No, this is what a true green obsidian is going to look like. Isn't that cool? I love these spheres that we have because as it goes through, you can see how it was cooling as it was going through, and there was different elements that were present during that as it was cooling. So to me, when I see a piece like this to me was created at the edge of a lava flow. So as the lava was going down, and it was cooling super fast, that lava is moving and bringing in the different elements as it cooled through. Right? Oh, I'm so excited. And you guys are getting even more excited about going to Hawaii. It's my first time and I'm going to have so much fun. But I'm going to be very careful. I'm only going to collect what they allow me to collect. I don't want to upset any native deities that are there. I've heard those stories. I don't want to touch that bad juju. Alrighty. So that's for the black obsidian. And there's so many different types of black obsidian, and like there's ones that are more dense, so it's harder to see through. There's ones that are really, really, really translucent. And I think, and that's all dependent on two factors. Where for the translucency, how much water and how much silica. Those variations will give you your density to your translucency. You guys are funny. I love you guys. So now we're going to go, there is a pretty rare form of obsidian. I don't have it here, but I will tell you about it. It's called fire obsidian. And what fire obsidian is it's an iridescent variety of obsidian. It's called fire because there's actual little thin layers of microcrystals in it, and those microcrystals are magnetite. But the microcrystals of magnetite are approximately the thickness of a wavelength of light. So you're not going to see it with your naked eye. You're not going to see the crystals, but it gives it this really cool, like, red iridescence to it. I wish I had some to show you, but I don't, but I didn't want to leave that out because I thought that was a really cool fact. Now we're going to get into rainbow obsidian. I love rainbow obsidian. I won't pull a Greg Brady, okay, guys? I promise. So rainbow obsidian is an obsidian with multicolored iridescence, and it's actually caused by inclusions of trace minerals, and those trace minerals are Hindenburgite, magnetite, hematite, and feldspar, along with other nanoparticles. So the vibrant colors exhibited by rainbow obsidian are a result of a phenomenon known as structural coloration. So unlike pigments that are absorbed and reflect specific wavelengths of light, structural colors arise from the interaction of light with the material's microstructure. So that's why you know how it plays along the stone and dances along. That is because of this structural coloration. And I have two different forms to show you here. I have one that's like a straight rainbow obsidian where you're going to see the colors go out gently. And then there's the other one that we call peacock obsidian because it goes kind of fuzzy. And that is simply due to how those microstructures inside are lined up. If it's lined up nice and smooth, you're going to have that nice transition. If those microstructures are a little bit scattered, that's where you're going to have that peacock obsidian, also known as velvet obsidian. So if you look here, this is where it's lined up nice and perfect. And when you see it like this, really good carvers, like the ones that made these Marys, can look at a piece of rainbow obsidian and line up their designs right in there to get the most out of that rainbow effect. And the thing that's really cool about rainbow obsidian is you see how this one kind of has a little bit of like that orange yellow, goes out to like these pinky purples, and then it's got like another like yellow bar, and then there's like a blue green bar. Another piece here, look at this one. This one here has got that really nice yellow with a little blue center, and then that blue ring. And then it's basically like a black obsidian out there. Right? So this is when those microstructures are so lined up perfectly, it gives it that really nice, smooth transition. And then as you see, as the light's hitting it, you see how it kind of just like glows and bounces through? Again, that's the structural coloration. For those of you that are here, I'm going to give you a little sneak peek, a little hint. If you like these pieces, they might be coming up in a SGTV soon. Hint, hint. And then the other side of that rainbow obsidian, like I told you, is what they call the peacock obsidian or the velvet obsidian. And so do you see that there? Do you see how it still has that color going out, but you see how it's more choppy? That's because the microstructure is a little bit off. You know, it's not so smooth. It's a little bit off. It's a little bit more like, and that's what creates this beautiful velvety texture. Whenever I see this, always reminds me of like crushed velvet. And look, if I turn it up like this, you're going to get that yellow. Turn it down, the pink comes out. And then on the back side, it's a lot more of that yellow gold. Let me see. Now you can really see that structure and that striation. When you put a light on it like that to really bring it out, do you see how you can kind of go deep into the obsidian? And you can kind of see, okay, right there, it looks like that molten magma, right? To me, when it's like this, it's really showing and going back to its original form. And it almost looks like if you look inside hard enough, it's going to start moving with like the magma was before it erupted. Cool. So that's what I wanted to show you on the rainbow obsidian and how it has. So a lot of times I've seen people teach that rainbow obsidian and sheen obsidian get both of it come from those gas bubbles. And I just wanted to really make sure that I let you know that from my research and from what I was taught, that's not true. The rainbow obsidian is from the structural coloration with those trace elements. And now we'll get into the sheen obsidian. Well, I'll teach you about that. I love sheen obsidian too. One time on a rockhound trip that I was on with my dad, I was able to get like a rock this big. I seriously took a long time. I was digging it out of the earth because it was a full silver sheen obsidian that was there. And so I was digging it out. By the time I got it out, cleaned it off, flipped it over because of the gas bubbles. When you flipped it over, it looked like golden sheen obsidian. I was like, wait, what? So you flipped it one way, it looked silver. Another way, it looks golden. And the piece is like this big. It's still sitting in my dad's backyard. Should have got it before this. So, Karina, I do think the regular rainbow is more common to what people see, simply because that's when people are carving it, they saw it as a higher quality, so that's what they carved. But if you go out and you find it in these areas, you're actually going to see pretty much an even amount of the rough out there of the velvet peacock and the straight rainbow. So in one way, I would say the straight rainbow is more common because of how much is out there. to buy in like carved forms. But natural from the earth, I would say it's about even. So, sheen obsidian. Sheen obsidian is a variety of obsidian exhibiting a sheen effect due to the trapped gas bubbles. So this is the one that has the trapped gas bubbles in it. These, sorry guys, I'm getting over something, so I'm sorry I keep coughing. So these gas bubbles create really thin layers that interact with the light, giving rise to the captivating sheen or glow that characterizes this variety. The iridescent effect of sheen obsidian is caused by the interaction of light with the parallel layers of minerals or crystals within the glass. When light enters the glass and interacts with these layers, it is refracted off in different directions and reflected, producing the mesmerizing play. And so there's two different ways to think about it between the silver sheen and the golden sheen. Some people say that it's different gases that are trapped within those gas bubbles to give it whether it's golden or whether it's silver. Other people say it's because it's how the gas bubbles are lined up. Are they parallel this way? Parallel this way. Either way, the gas bubbles have to be parallel with each other, but it doesn't, so that just means they can't be like this. But are they lined up this way in the stone? Are they lined up this way in the stone? You know, it's like, so that's the other way of thinking about it. So let me show you a couple of varieties that I have here. And then I always say, look at it for yourself. Look at the pieces you have, look at what I'm showing you, and then with your guys' knowledge, because you guys are all very, very smart, like, see what you have to say about it. Because just because I'm saying something or just because somebody else is saying something doesn't mean it's always going to be the best information for you. I'm a big person on collecting knowledge and each person putting their own knowledge and following your own path. So I just have to put it out there like that. It's something that I love to, I've been trying to teach my stepdaughter for a long time now. So I just gave her that speech. So I think that's why it's in my head. So here is a sheen obsidian. And you see how it has that golden color? And if you look, there's those lines, right? And again, just like the green obsidian sphere that I showed you, you can see how it's lining up. And so deep in here is those tiny gas bubbles. Let me see if I can. I really want you to see it. So let me try to get this as best I can for you. There we go. Can you kind of see especially along the edge here, the tiny, tiny little bubbles that are in there? That's what's creating the sheen. Cool, huh? Then if you look at this piece, you see right there? But there's one thing about this piece that I wanted to show you. So if you're looking here where I was showing you, you see all that silver? But look at his hand. See that gold? That's why I go with the belief. My belief is that it's the way the gas bubbles are lining up within the stone. Not so much the gases that are trapped. I think the gases that are trapped is not going to really influence it. But if you look at it one way, you'll see the silver. If you look at it another way, like if it hits, say it's hitting the flat side of the sheen, you might get silver. If it's hitting the narrow side of that bubble, you're going to get the golds. That's my thought process on it. Right? And then we have our in there. Look at that sheen. Sorry guys, the sheen's on our boobs. But you can really see the gas bubbles lined up. Does that help, guys? Does this help really kind of understand how this is being created and how that, like, all of these are there? Sorry, I get caught in just looking at the beautifulness. Right? Okay, this one I'm trying to capture a good thing for you because I wanted to show you something on this one. If you look at this piece one way, it basically just looks like a black obsidian, right? If you were just walking past this, black obsidian. And this is what I'm talking about those gas bubbles having to line up in a parallel fashion. As soon as it goes to the correct way, boom, turns silver. Black, silver. So this one definitely has it where it's being lined up a certain way. And as soon as you see it, it'll turn silver. But if you're not looking at it in the exact right direction, it's black. Parallel gas bubbles. Black, silver. Black, silver. And this one here even has some areas where it goes completely clear. Let me see if I can even get a light to go through it for you. So you see that where it goes really, really, really clear? You can see the black streaks. Higher and lower water content going through. And higher and lower silica content going through. And that's going to bring in those clear striations. And black, silver for your gas bubbles that are trapped. Pretty cool, right? So that's why it's like, this is why I really wanted to go in depth with obsidian for you guys, because we still have more to go and I'm already running lower on time, but obsidian is fascinating. It's so fascinating, and there's so many different types out there, and it's all been created from like violent occurrences from volcanoes to make this beautiful, beautiful stone. But the stone is also vicious. It'll get you. So now we're going into snowflake obsidian. Snowflake obsidian has the white or grayish spots that look like snowflakes going through. And that forms when the lava that contains small trace amounts of water, as the water is cooling, the water molecules escape from tiny bubbles. And in those tiny bubbles, where that was, let me speak. So where the water escaped, it left the little kind of pocket. And in that little pocket, cristobalite crystals grow. So those cristobalite crystals inside of the obsidian is what is creating that snowflake pattern. So the size and distribution of the cristobalite crystals determines the appearance of the snowflake obsidian. A high temperature polymorph of quartz within the obsidian. Right? So now we're going to look at our obsidian, or our snowflake. You're right, Karina. It's not just glass, but it's just glass, which is so cool. So this one here, so each one of those little blooms that you're seeing there is where there was little droplets of water. Those water bubbles escaped, and cristobalite crystals grew. And so this one here, you see how, let's get it in focus for you. There's like little bands from where the water was, little areas, and then more areas where there's like just plain black. And then there's this piece. You see where there's like a more dense cristobalite crystal, and then where it fanned out. Sorry guys, yeah, my fingers are getting black because I did burn this piece because I was doing testing, as I told you. I mean, I was having a great day today. You got me a complete and total pyro that was allowed to play with fire and rocks. I was enjoying myself. So I wanted to show you this because look at the two different patterns. And it's both snowflake. This one had tinier bubbles, so less area for the cristobalite to bloom. This one had bigger bubbles, bigger areas for that crystal to bloom. Cool, huh? It's spelled Cristobalite. Okay, now I have black all over my fingers, so if I get black smudges on my face, you guys have to tell me. Next, we're going to go into mahogany obsidian. Mahogany obsidian is the obsidian that has the two colors of obsidian that are like swirled and streaked together. The most common combination is black and brown obsidian swirled together. I also have a huge piece of mahogany obsidian at my dad's house. It's so cool. It's like boom, boom. Dug that one out myself too. And I'm just saying, if anyone that lives around here, around like SoCal area, and you want to go rock hounding for obsidian, let me know. We'll plan a trip. So here is mahogany obsidian. So mahogany obsidian is really, oh, look at that fracture. Right? You see that? You see that? It's because it had a little chippy there. And here at the ends, makes those little domes. So this is the mahogany obsidian. You see how there has that reddish brown. This is due to a trace element of iron within it. And sometimes you can have like this piece here where it's very thin, little pieces, or pieces like this that are filled with that iron inclusion. Right? I love mahogany obsidian. Alrighty. You use mahogany obsidian for difficult coworkers? I love it. Tell me the truth. Do you wear it? Do you have it on your desk? Or do you throw it at them? Asking for a friend. So now I'm going to go into another formation. And a lot of you guys know this. It's called Apache Tear. Apache Tear is a specific type of obsidian that is found in the American Southwest. Apache Tears are characterized by their smooth, rounded shape and deep black color. See that natural round shape? Kind of like oval. They also, almost all of them are going to be narrower on one side and wider at the other. So it actually kind of looks like a teardrop. So these nodules have been tumbled and polished by natural processes, such as water erosion over time. They typically measure a few centimeters in size and exhibit a distinct conchoidal fracture. You see how they have little teeny fractures all over them that make that indent? Those little domes I was talking about. These nodules are composed mainly of volcanic glass, but they might also contain small amounts of mineral impurities, giving them a dark brown or reddish tint. These impurities can include minerals like magnetite, amphibole, and biotite. The teardrop shape of Apache tears is due to the way that they are formed. They are thought to form when small bubbles of gas escape the lava as it cools, and these bubbles cause the lava to form in teardrop shapes. They are said to bring good luck to the wearer. So basically, there's bubbles that are coming up, and when the bubbles come up, it pops some of the magma out as it's molten, and then as it's falling down, it solidifies in these shapes. And that's why, because as it's going down, gravity is pulling the magma down this way, and that's why you're going to have that shape where it's going to be wider at one end, narrower at the other, where this one shows it very strong. And this one is not as strong, but you can still see that it's thinner up here and wider down here. And that's always why they're going to be found in shape and like this. And it's also why very rarely you're going to find any that are big. Because, I mean, it has to do to basically pop. You know, like when you're cooking something and there's oil in your pan and you accidentally introduce water, you know how it pops? Same thing. Water is introduced and pop. So now I'm going to go into a little bit more detail where we're going to talk a little bit more trace element. And I still have more for you. I just got to keep hurrying up because we're almost done. So obsidian is primarily composed, like I said, of the silicon dioxide, which is the same chemical composition as quartz, but it has a completely different structure due to the rapid cooling from the molten state, instead of quartz that gets to work its way and create structures over time. The chemical composition of obsidian is, like I said, 70 to 75% silicon dioxide. But as we just looked at, they have the little differences. Iron impurities is what makes it appear the brown or black. So it's that iron is like what's going to make, like I said, the mahogany. Magnesium can contribute to the green coloration in some of the obsidians. Calcium can affect the color and properties of obsidian, often resulting in browns and grays. Sodium and potassium are alkali metals, and they can be present to influence different properties in obsidians as well. Aluminum is another element that can be found in trace amounts of obsidian. And then, of course, water. Water is a key thing. So some obsidian may contain small amounts of water, typically in the form of microscopic bubbles or inclusions. All obsidians are going to be between 5 and 6 on the hardness scale. And again, they're amorphous. Now, if you came to the last SGTV, you heard me go off on Agni Manatite. Agni Manatite is, some people say it's a true tektite. Some people say it's a pseudo tektite and it's an obsidian. And let me give you a quick rundown on it. This is it. I also have it in a couple of forms. I'm going to show it to you, and I'm going to run through this really fast because I know we're getting close. Agni, right? This is how it looks naturally as it's found. This is trying to polish it, but it still has a bunch of those rough areas just due to the stone. And it's really hard to get it a really shiny polish. This here is one of the shiniest pieces I've ever seen them be able to get, right? But it still has bumps and areas and holes, right? And cracks. If you see a big piece of something polished saying it's Agni and it doesn't have any of these little things, it's not going to be a true Agni. So Agni comes from the Java Islands. It's the only area where it comes from, and that's home to over 30 volcanoes. Silicate lava hardens during the eruptions and turns into dark glass stones that rain across the island. Several factors contribute to the authenticity of Agni as a real tektite. The formation process of tektites is a complex one that involves high temperatures, pressures, and velocity. When meteorite impacts the Earth's surface, it generates an enormous amount of heat and pressure, causing the target material composed of the rocks and soil to melt and vaporize. The molten material is then ejected into the atmosphere where it cools and solidifies before falling back down to the earth as tektites. Now I have a little thing for you. This piece here is an actual tektite. Okay, so this is a true tektite that formed through that process. But notice the striations on it. Looks similar to this, doesn't it? So obsidian, as we just learned, is created from also that really strong heat and pressure. But obsidian is from lava, volcanoes. But still, regular tektites, agni, and regular obsidian. Let me grab a piece. All of these are all forms of glass. Tektite, agni, obsidian, all forms of glass. Agni is estimated to be about 700,000 years old. So this is where we're going to get some down and dirty. Some people say agni is a pseudo-tektite. Some people say it's a real tektite. This is where my experiment came in, right? So what's the difference between a tektite and obsidian? Obsidian was formed by volcanoes, right? Tektite was formed from a meteor impact. Both created glass. But they all have different trace elements in them. Like some tektites are black, like this one. This one came from Taiwan. Others, like moldavite, where it hit the Czech Republic, is green. Others, like the one that hit in the Libyan desert, is gold. All due to the trace elements. Just like there's different colors of obsidian due to the trace elements. But this is where I get excited. Tektites can be distinguished from the much more abundant volcanic glasses, obsidians, by the negligible water content. So even though it's all silica dioxide base, 70 to 75%, tektites have less water. Obsidians have more water. If you take a tiny small splinter of tektite and you go to melt it, it's going to melt. If you take a tiny small sliver of obsidian and you go to melt it, it's going, because of the different water content in it, it turns it into steam, and so it just kind of gets like white and crumbly and goes to steamy. You want to know what I did for my experiment? I took a small sliver of tektite, I took a small sliver of obsidian, and I took some small slivers of agni, and I melted them all to see what would happen. Do you guys want to see what happened? Yeah, I'm excited. So, as you can see, I got my torch, filled her up with butane, and went to work. I'm not going to light it here because it's not safe to do it inside. I did do this outside where it was safe. Maybe if you guys like it, I might show you I might do this again and like do a video of it. So if we look here, do you see how that looks like a whole bunch of melted goo? That was the tektite. When I hit it, and you can see by the nice mark there, I hit it with some really high heat, and it actually melted it into that goo. This here was the pieces that it started from, and I turned it into that. Cool, huh? Turn it around. See this piece here? Started out from a piece like this. And look at it now. You see how it has that white ridge around it? That's where it actually started steaming and breaking down. That's the obsidian. So same amount of heat, same time of heat. This started breaking down and going white, where it was steaming away, and this one melted. Then I took Agni. That's what you see here. See how some parts are melted and some parts turned white? It acted like the exact medium. Some melted, some steamed. So do you know what that tells me? That my hypothesis has been, I feel justified in my hypothesis of what happened to create Agni. I think that it is a mix, right? I think it's a complete mix. And what happened was the reason why they say it's not a tektite is because they haven't been able to find where the meteor hit in the Java Islands to create it. Everywhere else, they've been able to find the exact area where the meteor hit. I think the meteor came down and hit inside of a volcano. That's my opinion. Again, you make your own choices. I think that's what happened. What do y'all think? Can you guys give me some of your thoughts? So the melted silica sand, that's different than obsidian because that was created, there's so many different trace elements in there, and in sand, there's a lot more than just what's in obsidian. So yeah, it's making glass, but it's different than what we're kind of talking about here. I think it's a medium. I really do think it's a hybrid between the two. And that's why there's some people that say one way, some people that say the other. But so far, no one's been able to prove one way or the other. So that, we are out of time. That's about all I have for you today. Did you guys like it? Did you guys enjoy this really deep dive into obsidian? I did. Some really quick fun facts about obsidian. Did you know that because of that conchoidal fracture, like we were talking about, and how sharp obsidian can get, did you know top surgeons today still use obsidian blades when they have to do precise cuts during surgery because it gives them a smaller, finer cut than any metal will? Alrighty, guys, so that's all the time we have for today. But I did want to do a little giveaway for one of y'all that's here. If you would like what I have, please say yes, me, oh my gosh, I need it. And I wanted to give you guys a really cool golden sheen obsidian athame with a little heart on it. You want to see my hair? I have too much of it. I need to cut it off. And it's going blonde again. I stopped dyeing it. So it's going blonde again. But yeah, if you guys would like this, please let me know and I'll choose a winner. Alrighty, guys. Polly, this is for you. Have a wonderful night, you guys. I'm so excited. Thank you for joining me. Just as a reminder, we have our next SGTV on next Tuesday, September 10th at 3 p.m. Oh, no. That's not correct. It's October. Oh, my gosh. It's next Tuesday, October 8th. I was thinking about the last one. So yeah. So next Tuesday, October 8th, 3 p.m., we will have so many things for you. I do have obsidian in there. I have some other items for you. I'm excited to see you all. Thanks so much for coming. You guys make it a great time always. I hope you guys learned some interesting facts about obsidian. And I would love, love, love for you guys to let me know how you liked it and what you might want to learn next time. Thanks, y'all.